Welcome to the last week of remote learning. What I'm going to do today in this short video is just to review very quickly what we've done so far in algebra, just a reminder what algebra is and how we can use it. I'm also going to remind you today what BODMAS is and how to use BODMAS or order of operations, because you'll need to know that as well. Then I'm going to show you some examples of how we can use algebra to create formulae. I'll explain what all that is in a minute. I'm going to create something called formulae using algebra, which is really useful in maths, it's really useful in science, it's really useful in geography, it's really useful for all kinds of things. In computing, if you're programming video games or whatever, or just making spreadsheets, it's very useful for that as well. So algebra is unknown numbers. So anything you have, any sum you have, any equation you have with unknown numbers, we call it algebra. And there's two main ways that we use it. Either we have an unknown and we've got to work it out. So a plus 2 equals 7. Well, then a must be 5, because if I took away 2 from each side, I'd end up with a equals 5. So we have an unknown number and we need to work it out. The other way that we've seen how to use it is if the number changes. So if I said I need to have 2 chocolate bars for every child in my class. Two chocolate bars for every child. What shall I say? Let's put Z. Z equals chocolate bars. So how many chocolate bars do I need? Well, if I have 30 children in my class, then it's going to be 2 times 30. Turn that into a Z. Oh, 2 times 30, which is obviously 60. So I'm going to need 60 chocolate bars. If C says, well, actually, there's another class that only has 25 children in it, then I go 2 times C is now 25, which is 50. So I need 50 chocolate bars. Okay, so algebra can either be an unknown number which we need to work out, or it can be an unknown number because it keeps on changing. Just a quick reminder of BODMAS, because we're going to need that today. We use BODMAS a lot in algebra. Remember, BODMAS is the order of operations. So when you look at a long formula or a long sum with lots of different things in it, you don't go from left to right. You have to do it in this order. So you have to solve anything in a bracket first. O, which actually stands for order, but we can think about it as other. So like squared, cubed, square root, things like that. Then we need to do all the divisions, then the multiplications, then the adding, then the subtracting. So that's why you end up with these two, which end up giving you different answers. You probably all remember doing this now. So in this one, we've got to do the brackets first. So it's 3 plus 2, which is 5, times 4 is 20. In this one, there aren't any brackets, so we can ignore that. There aren't any squaring, so we can ignore that. There's no dividing, but there is a multiplication. And the multiplication you do before the adding. So in this case, I'm actually going to do 2 times 4 first, which is 8, and then 3 plus 8 is 11. So you can see how the order of how we do things is very important, because it gives us completely different answers. And the same goes for when we're doing things in algebra. Just a quick reminder. So, formula. So we make up formulas to show people how to do things. Let me give you a really nice example of a square. Here's my square. Now, I want to make a formula, or a formulae. I want to make a formulae which tells me how to find out the area of a square. It could be the area of this square, it could be the area of a tiny little square, or it could be a square the size of the United States. It doesn't matter. So how do I write a formula? Well, remember that we know in order to find the area of a square, we do this side times this side. That's how we find the area of a square. However, a square being a square, this side and this side are the same length. I'm going to call them, think of a random number, Mr. Dobson. Let's go for m today. Whatever length that is the same as that length. So I need to do m times m. Now, m times m, another way of saying one number times by itself is squared. That makes sense, doesn't it? So then I can substitute that in. Okay, so this triangle here, each length is actually 4. So I need to do 4 times 4, or, as my formula says, 4 squared. They mean the same thing, by the way. 4 times 4 and 4 squared mean the same thing. So the answer is 16, whatever it is, centimetres squared. I could have another one then, which is 8. So now they're 8 meters. So I need to do 8 squared, which is 64. Whatever it is, centimeters squared, whatever it is, we measured it in. That might be 8 meters, 8, whatever. Okay. So that's what we've done here is we've made a formulae to work out the area of any square. Could we do the same with the perimeter? Perimeter of square. Well, the perimeter is going to be m plus m plus m plus m. Remember, it's a square, so all the sides are the same. And there's always going to be 4 of them, isn't there? So the perimeter is going to be m times 4, which in algebra, we know now, we write just as m4. Sorry, m4, that's a motorway. 4m, 4 m's. There's 4 of them, 4 m's. So let's think again. What is the perimeter of my square where m equaled 4? Well, when m equals 4, perimeter, and remember I've chosen m just because it was a random letter. It can be any letter you like. Perimeter equals 4m. So 4 times 4, which equals 16 centimetre. Remember, perimeter isn't squared because it's just the length. Or how about if my length was 2? So if m equals 2, if the length of this was actually 2, it would be 2 times 4. 4m, 2 times 4, which equals 8. Okay, so I've now made a formulae to how to work out the area of the square and how to work out the perimeter of a square. You can do that with lots of other shapes. I think they are covered in the book, so I'll let you discover those. But let's think about another way. How about, I think I used this example before, if you're saying, in order to, let me think of a good example. You need to buy some books for a class. You need to buy some books for a class. So you obviously need, how many books do I need? Well, the books you need for each class is going to be, I'm going to call it S for no reason. So books for class equals size of the class plus 1 for the teacher, because the teacher needs one as well. So however big the class is, you also need 1 extra for the teacher. So in year 6, there's 29 of us. So the amount of books I need is 30. However, year 4, there's 24, plus 1 for the teacher. So that equals 25 books. So we've created a formulae to tell us how many books every class needs. So we don't have too many and we don't have too few. And you can see that for each of these, S, that looks like a 5. That was a bad choice of words, a bad choice of letter really, wasn't it? There we go, S. Or maybe I'll draw it in the, what's the way that you guys draw it? There we go. So the amount of books I need is the amount of children in the class plus one more for the teacher. So now I've created a formula for how many books I need for each class. Now when this gets harder, you may need today to use BODMAS, so just make sure that if there's more than one thing in it, if there's times and plussing going on, make sure that you are following BODMAS, especially if there's brackets or squares or whatever. So take a look at the White Rose video now. It's quite good, it takes you through it quite slowly, through some patterns at first, and then you can see that it's going to end up write a formula for the area and perimeter. It's a rectangle, so I've shown you how to do it for a square, now you have to do it for a rectangle. And then there's a square. So there we go, I've given you the answer to that one already, really. And it takes you through it quite slowly. Again, it looks complicated, but actually it does go quite slow, so I think actually if you take your time, it's not going to be too bad. As always, ask any questions on the comments. Either myself or someone else will be able to help you. Please keep the comments free of anything that isn't maths related, just because it makes it much more efficient. And I'll see you all today at 12.